Okay, so I'm knee deep in a wood project right now, and I thought, what better time to talk about wooden roller coasters? So let's get into it.
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? On today's episode, I was throwing away an old skateboard ramp that I had made, and I was looking at all this good wood around, and I was just like, I should talk about wooden roller coasters today. And I was like, different from my normal. It's like, you know what? I've got enough wood sitting around. I'm like, let me put this wood to good use and let's make a little example out of it. So that's what I'm going to do. I'm going to build a section, a very small section, mock section of a wooden roller coaster. So if this is your first time here, make sure you like and subscribe. I do stuff kind of like this all the time. Normally I work on a much smaller scale. As you know, this is my new thing. I only do videos while people are mowing their lawn and doing other things around. So excuse the background noise from time to time. Sorry about that. Okay, so let's talk about the terminology around a wooden roller coaster. I'm going to be talking about this stuff and doing a best demonstration as I can. I can't promise everything because the first thing I'm going to talk about, what's a wooden roller coaster sit on? Wooden roller coaster sits on the ground, obviously, but it sits on footers. The footers of a wooden roller coaster, unlike a steel roller coaster, aren't typically that deep. They're only down 1.5 feet, 2 feet into the ground, not much at all. And now people are like, oh, wait a minute. Wooden roller coasters are huge. How come that little footer is going to hold that big structure? It's because the structure is so big. That's how those footers are able to do that. It's not so much that you have like a steel roller coaster. There's 1 footer or maybe 2 footers for a 50, 60, 70 foot long piece of track that has the entire train going over it. Typically, wooden roller coasters have a footer every square, I'd say it's close to 4 to 6 feet. Every 4 to 6 feet in each direction, you have 1 footer. So there's hundreds, there's thousands of them on a roller coaster, unlike a steel roller coaster. So I can't actually do a footer here because the garage I have, I'm not going to drill into it. I'm not going to anchor it down, but the footers are quite easy. Sometimes you can actually buy them from like Home Depot or something like that. It's just a little cinder block type looking deal with a piece of wood on top. Honestly, for low stress areas around stations and stuff like that, those sort of things work fine. There's nothing wrong with those. So what I'm going to move on to next is what's called a bent. Now, as you're going along the roller coaster, imagine going straight down the track. Every time you come to a section where it looks like there's a vertical upright holding the track up, that section, that pair, is a pair of bents. Those bents go from the ground up. So let me start making some of this stuff for you. Okay, so what I've got here is 2 different sets of bents. And typically, when I get large wood erections done, I typically make them on the ground first because an erection is easier to get up with wood as long as you're on the ground. So you typically build the bent on the ground and set it up that way, depending on the length. I mean, sometimes the erection's really big, sometimes it's small. But the hardest thing to do would be to build the entire thing on the ground and lift it up because you have wood. It's flexible. Wood typically doesn't stay that hard, especially the older it gets softer and it gets limper. So it's like you're trying to lift up an entire bent structure with one erection and the thing just sags and falls apart. Nothing happens. So what you want to do is you want to make sure your erections are big enough to get work done, but small enough to where you can easily manage it and handle it down. Sorry if I'm waving around, there's a fly going around me. Flies, man. So these are going to be my 2 sets of bents. Again, much smaller scale. Keep checking the computer to make sure I'm somewhat in a frame. So the bents are these guys. Imagine them standing straight up like this with the track going through the middle of them here where my hand is. Yes, I apologize. I'll have to use a lot of digital zoom for a chunk of this video. Okay, the next thing we're going to do constructing these bents is we're going to put the header on the top. Now, I'm using much smaller scale headers, but these are the headers that I'm going to use. Now, what is the header? The header, also the ledger, there's an interesting kind of definition choice between the two, but not really. They're both terms that can be used interchangeably. It's either a header or a ledger. It stands for the piece at the very top that the track is going to mount to. The track mounts to the header. So the header or the ledger is the very top piece that the laminate stack is going to mount to. We'll get to that in a little bit. But the header ledger is typically a much thicker, stouter material than the bent is or anything else. So this is going to be my header for this little particular demonstration. I'll use that on both sides, and we'll end up making something kind of along these lines. And now basically I'll grab a screw gun and start putting these things together. So while I'm doing this, basically I also wanted to say that the header, probably going to crack these things in half because I haven't pre-drilled a hole at all. Wooden roller coasters, we use a lot of steel hardware like big nuts and bolts and things like that. Typically not a lot of wood screws until you get down to the lower stuff. All right, when it comes to wooden roller coasters, the difference really between a header and a ledger is that, now this is not a guaranteed thing, but a lot of times a ledger is referred to when it's made out of steel. But I have heard people refer to a ledger in wood. Ooh, missed that one. I've heard people refer to a ledger in wood. I've heard to them refer to it as in steel. That's typically what it is. Again, you can talk with a lot of people. You talk with a lot of people and get the same thing with different answers. Well, it just depends on who you talk with. I've worked with wooden roller coasters, but they haven't been my thing. They haven't been the forte of what I do. Okay, so with these guys, the whole assembly that I'm making is a bent. That's typically the term for it. The whole section is called a bent. When the coaster starts getting higher, or when there's areas where there's lateral G-force pushing on some ways, you have these big legs that kick out to one side also. Basically, it would look something like this. Okay, so when I take the bent post like this and I put a diagonal kick out on it, or maybe some lateral support, this is actually a batter at that point. So you have bents and batters. This would be a batter post. They could be vertically, depending on the side of the structure. They could be kind of diagonal like that. It all depends on what it's doing. The terminology is very, there's a lot out there. And you could talk with people that have worked on wooden roller coasters for a long time, and they will lay all sorts of terms down that probably a lot of people haven't heard. So I'm trying to stick with more like some mainstream stuff that you probably hear. So it's like, okay, the section is a bent. Here's your bent posts. Here's batters off to the side. You have batter posts. But now what we need, because this guy's going to flex all over the place, we're going to need some diagonals and some ribbon boards in here. So first I'm going to start with the lower ribbon boards. So let's do that real quick. All right, so what I'm going to work on now is the diagonals and ribbon boards. So diagonals pretty much do like this sound. They go from one side to the other, and they keep the structure from swaying really far side to side. So I'm going to put a couple diagonals in, and then the ribbon boards are pretty much used to tie left to right. They could be used along the bents or underneath them. I can't remember where the definition lies, but there's also horizontals. I think those are for when they carry weight. Like if you were to build a bridge over an area where the train had to pass by, then you would use a horizontal to open the lattice work up for the train to pass through. So let's put in some diagonals and some ribbons. Again, not putting a lot of time into this, but I figured this will probably be better than trying to make it out of cardboard, which I know everyone loves. I know. We love the cardboard. I understand. So here's what I'm going to do. I'm going to kind of make this go a little bit faster like this. Ah, the joys of an active garage. Cars coming in and out, everyone coming in and out. It's all fun. It's all good stuff. All right, now what I have here is essentially two bents, pretty much ready to go. And again, like I said, if these were smaller bents, I'd say within 20 feet of height. The bents are typically built on the ground, and then they pick them up with a great awl or crane or something because they're not too heavy, and you'd stand them upright like that, and then attach them to the footers down below. Now, a lot of times what happens is that on a roller coaster, they've already put wood in the footer in the ground, and the bent is simply just being attached to that wood, whether it be on the side or whether they put it on top like that and attach it in there. But that's the next step. So what I'm going to do for this one, since it's free floating, I'm going to take this guy and I'm going to just set them up like this. I'm going to attach a couple more ribbon boards to them just so they got some sort of stability. And let me do that real quick. For those of you wondering what I'm doing, these are basically, these are Torx. They're T10. They're really tiny, so that's why I'm having a lot of trouble starting them. T10s. All right. Set this up right. So I just put in a horizontal, although the horizontals with no weight above them are actually called just ribbons. Putting in some ribbon boards. More screws, always more screws. So it used to be old wooden roller coasters were always built with nails. And now these days, pretty much all of them are built with screws. They were built with nails because it was just more economical to not have to worry about the screw, but now the screws are quite cheap due to manufacturing stuff. So most parks use screws. The only downside to that is that when you have a lot of shrinkage. We'll do some on this side as well. Okay, so essentially, this is our roller coaster track, kind of. We have bent, which is, this is a bent because the train would go, let's just say this way. This is a bent right here. This is a bent right here. They're typically marked with tags on them with numbers somewhere typically in the station. The bent will be marked with a number 1, and then the next one ahead of it's number 2, 3, 4, 5, 6. By the time you get around to the lift hill, they're typically in like the 50s or the 60s, and then they just keep numbering around from there. The one I worked on, I think it had upwards of 500 or right around 500 bents. And of course, each bent, it could be something simple like this, was simply just 2 bents and then 2 posts and nothing else to it. Or it could have a lateral, kick out off to the side where they might be expecting some side forces, and then ribbon and bracing and everything else. Or it could be an area where we've taken header or ledger material and put it this way. That way it builds a bridge where the train can pass underneath it. Either way, on top of it, the bents have to connect to that horizontal, and that horizontal is typically, they're made out of like steel or I-beam or C-channel or something to support the weight of the wood structure up there. Let's talk about some care and maintenance here. One thing is going to be noticing wood that's broken. So if a wood gets a crack in it, it typically needs to be replaced. There is a difference between a crack and a split and a check. There's a difference between those. Basically, this wood along its natural lines will tend to check close to knots and things like that. And that's where the wood starts to splinter and open up and it starts coming out towards the side. That's just a check. It's okay, actually, when you see wood split like that. It's not the best thing in the world, but it's still okay. It's still safe by all means to operate. A crack is when that check makes it all the way out to the side, especially if it makes it to the hardware holes. If you've compromised the hardware mounting the wood, in this case the header or the ledger, to the bent post, if you cracked anything around that area, that's no good. That means that header needs to be replaced. The headers are the worst things to replace because they're big, they're heavy, and typically they are high up in the air. So an actual header is made out of something like 4 inches thick, about a foot tall, and then they typically run between 8 and 15 feet wide. And then everything else is on top of that. Some stuff we haven't talked about yet, let's talk about real quick, is walk boards. So next to the track, we extend the header out on both sides. If you're going to do something, you might as well do it, right? Okay, so basically the headers most of the time extend out to the left or the right, depending on banking and which way it goes. For flat track going up and down hills and stuff like that, the header is extended to both sides. If you have a piece that is banked really steeply, let's say really steep on this side, then typically the header is extended towards the downside. The top won't really have much of anything, but the downside will have more header on it. And the reason for that is to put on something like this, which would basically be a walkboard. Walkboards are a set of boards put off to either side of the track, one or both. And the walkboards, what they do is they allow workers to walk up and down this track every morning, every evening, even while the ride's running sometimes. The workers will need to gain access to areas. So how do they get there? They typically walk, just like everywhere else. So a lot of times they'll have boards just like this, slanted at an angle, but they'll have smaller boards nailed to them about every foot. And it kind of makes like a stepped ladder going up the side. But those are walk boards. They could be put on either side. Typically, walk boards are spaced out far enough so the handrails would come up on the outside of this, and then you'd have the handrail running along the top. Why do we need handrails on everything? Because if employees are walking the track to work on stuff, they need to be in an area that's safe to do so. They're going to have their climbing harness on. They're going to be tied off to the track. They're going to be tied off. If you look at the handrail underneath, there's a steel cable that runs the length of the handrail. That's actually for the climbing harness to clip onto as they walk the track. But they need to be tied off. They need to be safe. And the eventuality that a train becomes stuck somewhere, like it hits something, the track comes apart, and the train stops out on the track, then people would need to walk in that same area. Now, typically it happens at a low spot, typically where it's nice and rounded, but if it were on some extreme angle for some reason, don't know why, the guests would also be taken off one by one, and they would be given like a climbing belt or harness so that they too can be tied off to the structure as they're coming off the train. Safety first, it's always paramount. So we covered some cracking in the boards, we covered checking. Most of the time what happens is the ribbons on the side here, they typically just come loose or come off. They will either pull through the hardware gets over tightened, and then the wood expands and contracts and basically just pulls through, and then the ribbon board just comes loose. If you've ever seen a roller coaster shut down, because they're like, oh my gosh, the wood's falling off of it. It's typically just one of these little ribbon boards where the end has come undone, and now it's just flapping in the wind every time the train comes around. It's really not a harm to anybody unless it's over something. Like if the track passes underneath, big problem, because then you could have something fall on the train. Nobody wants that. But a lot of times it's just a ribbon board, something along those lines that comes out. It's a small diagonal. It's one of the. It's typically something minor. It's never really anything like a bent. It's never like the header or the ledger that gets all messed up. Those things, if they get messed up, typically the ride doesn't open that day because that is a lot of work to get down to the header. What else do you have to do to these things? On a somewhat regular basis, let's talk about the wood. The wood is a living, breathing thing, quite literally. So on a somewhat regular basis, the wood has to be watered. You literally, like wooden roller coasters will go around and install sprinkler systems on them, and then at nighttime, a couple of times a week, depending on your environment, they'll turn those sprinklers on and literally soak the structure down. Areas where you have a lot of humidity and a lot of rain all the time, they don't need as much as that. So like I'm out here right now in the Midwest, and there's enough humidity and rain out here to where the wood will survive just fine. You don't really need much work to it. Back California, where I came from, there's hardly any humidity out there, just a little spike in the morning time, and that was it. So we had watering systems hooked up to the woodies to keep them nice and wet. So it's important to keep wood wet. That way it stays flexible, right? The whole structure bends. If you've ever seen a wooden roller coaster go around the bend, the whole structure kind of like leans over as it goes around the bend and comes back. People that see that for the first time go, oh my gosh, that was crazy. The thing's about to fall over. Did you see that? Perfectly fine. Supposed to do that. Age-old method, if it doesn't bend, it will break. Same thing here. If wood dries out and you get nice hard wood, like, hey, sometimes you want stiff wood, right? For certain things, but not in this case. You want actually nice pliable wood that's flexible because it will handle vibration, it will handle shock load and come right back to where it's supposed to be. You dry wood out and give it the same shock load, boom, broken wood, downed roller coaster. It's no fun. So got to keep the wood nice and wet. Another thing parks like to do, some parks, especially around the boardwalk areas, I think a lot of you know where I'm going, is they like to paint the wood. That is a form of preservation. So you typically paint the wood and it actually kind of locks in the moisture that's inside of there. And then it's a lot harder to rot out, especially on boardwalks where you have harsh elements like sea salt and stuff like that trying to get into the wood. In that case, the painting on the wood is more of a preventative measure than anything else. So for woodies near the oceans, it's very important to seal the wood so that salt and that corrosive environment doesn't make its way into the wood because it will dry it out and mess things up. Okay, let's talk about the laminate stack. Dun, 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 dun. What's a laminate stack? The laminate stack is the track. The track, that is the laminate stack. So where's the track go? The track goes right on top of your header slash ledger. That's where the track goes. It goes right here. So why is it called the laminate stack? Let's take a look at that. Here's my laminate stack right here. Super sweet laminate stack, right? Oh my gosh, that's amazing. Ryan, you're so amazing. I know I'm cool, right? Yeah, you're so cool. Wow, we wish we could do laminate stacks like that, but you can't because I'm so awesome. All right, let's look at this from the side. So here's your laminate stack that the train's about to run over. How much does a train weigh? Well, each coach probably weighs about 1,500 pounds, plus two people, right about 2,000 pounds. Let's just say a ton. Each coach weighs a ton. What happens when the coach rolls over this area? You have 2,000 pounds of weight coming over this area. What happens in the center? It bends. If I push a little harder on this, it's going to break. Like, that's not good. So, how do we fix that? Well, let's see. We need the track to bend because it has to follow curves. We have to be able to take it and follow curves. We have to be able to twist it from side to side. So we need to do that. Well, what happens if we got these huge pieces of wood and just cut a solid wood member out of it? You could do that. A, good luck finding that wood because that's going to be really expensive. And B, good luck cutting it into that shape because now you're going to need to cut the arcs and the curves into it. I know people with chainsaws are like, I could do it. It's like, yeah, no, let's not. Okay, so what we do is we take flimsy wood, something lightweight and thin, and we put it down. But the coaster will break that as soon as it goes over. In fact, we can't move a coaster over that spot. Well, is it something with wood where like the coaster goes so fast it never touches it? Because we have G-force, right? As you're pulling up out of that curve at the bottom, you have what, 2 to 3 G's of force, which means your 2,000 pounds is now 6,000 pounds at 3 G's of force, right? 6,000 pushing down on there, you are going to break this. So what are we going to do? We're going to take another piece and put it on top of that. Amazing, right? But wait, there's more. Check this out. We're going to put another piece on top of that, and we're going to stagger it. And we're going to put another piece on top of that and stagger it. And then we're going to fit another piece on top of that and stagger it. Now what we've got is a very thick laminate stack on there. But will it still move? Yes, it will still move. But right now it only moves because it's not anchored together. If I went through and put screws every 2 inches into this laminate stack, this thing becomes rock hard wood. I mean, we're talking little blue pill wood, like really solid. And now the train can run over it. Kind of. Well, we need a little bit. It's not in the right shape for a train to run over yet. So let's develop this idea just a little bit more. We're going to need bigger wood. Okay, here's my bigger wood. I'm going to split it in half. Right there. I know this is not going to like getting drilled into at all. Especially near the edge like this. It's gonna hate this. Oh my gosh. I'm gonna snap every piece of wood, huh? Yep, every piece of wood. I'm gonna break it. Aren't you worried about it? No, I'm not worried about it. Why? Because this was trash anyway. It's gonna throw it away, so it's no big deal. Split that wood, I don't care. Three layers of laminate stack. That's really thick. But wait, there's more. If you call now, I'm going to throw in 2 more layers of laminate stack. That's right. Well, 1 layer for each side. We're going to move this up to 4 layers. That's right. This is a quad laminate stack. You can look that up in a dictionary, and you know what? You won't find it because I just made that up. That's right. People say, Ryan, I think the heat's getting to you. And you know what I say? I say, shut up. It is getting hot, though. I feel like I may have lost a piece to my wooden roller coaster. Okay. All right. So now we have our patented quad laminate stack here. 4 times the laminate stack. All right, we got these guys here. So now this isn't gonna go anywhere. Right now, honestly, the way it sits right now, this model, I could probably put a couple 100 pounds on this right now and it should be fine because this stack isn't gonna go anywhere. All right, there's a laminate stack from the side, right? It's down there. All right, now, if we were to put roller coaster wheels on top of this, do I have any roller coaster wheels? I don't have any roller coaster wheels, but I did find these. These should work just fine as an example. All right, so roller coaster wheel on top of the laminate stack. We having fun, right? Guide wheels on the side of the laminate stack. Not the best. I mean, it'll take it, but not the best. And then upstop wheels, right? On the upstop wheels, how do we, well, if we put the upstop on the laminate stack and go, well, I can't make it past the headers. I can't, that's not gonna work. That's not a helmet, that's a head. I got that line from Iron Man, just jumped in there. That's not gonna work. Show them, try to put your head in there. See, that's not a helmet, that's a head. Software shit. Anyways, so we need to do something for that upstop wheel. So how are we gonna do that? And the guide wheel should have a little bit of a beefier surface than that. So what do? In comes the top board. Okay, the top board is actually what the roller coaster runs on. Let's get those installed. Oh, man. Installing the top boards, I think I just shattered the whole laminate stack, but that's what you get for trash models. Okay, so now we have our top boards on there. This kind of looks more correct, doesn't it? And that's like, oh yeah, roller coaster tracks look a little bit thinner, okay, or thicker. All right, so this is the top track. Now, your road wheels, they go right here on the outside of the top track. Why do they go on the outside? Because the outside is where all the weight is. That the weight is in line with the laminate stack. So you can't put the road wheels in over here. You have to put them out over here on this side, because here you're just going to crumple the side of this board in. So this is where your road wheel runs, is right on the outsides of those two. Guide wheels, where do they go? Well, now they have a dedicated surface on the inside. So now the guide wheels go right there. This board, if you look at it, is typically much thicker than your laminate stack is. Your laminate stacks are this way, and then these boards are typically much thicker. They handle it's about 2 inches thick on there. But now what do we have that we didn't have before? We have an area for the upstop. Remember the upstop? We now have an area for the upstop to go right there. Now the upstop can go there. Okay, now we got all the wheels in. We've got upstop wheels, we've got guide wheels, and we've got road wheels. Awesome, we've got everything. Is that it? Are we done building it? Almost, almost. So the last thing to do with this is to put the actual running surface on. Now, for the purposes of this demonstration, I'm sorry I don't have anything sitting around the garage here that I could use as a steel surface, but what they do is they take plates of steel. This is steel that's about 4 inches wide, roughly 3 to 4 inches wide, and they put it right on top of this surface, just where the road wheels are going to be. They drill holes in it and then countersink the holes, and then the screws that hold that top steel, that's what that's called, the screws that hold that top steel down, pretty impressive actually. The screws that hold the top steel down go all the way through the top steel, through the entire laminate stack. And then they have hardware on the bottom that tightens that up. So if you can imagine, just hundreds of screws on top of there, all towards the outside edges, and that's so the road wheel can run unobstructed down there right in the middle. The same thing happens with the guide. The guide steel goes on. Guide steel goes on right here. On the inside, those screws are put from the inside and they come all the way back into here. They come all the way out the side. When you look at roller coaster track on Woody's and you see a bunch of screws sticking out of the sides, that is the guide steel hardware. Runs all the way through this board, comes out the side. So now you have hardware that goes all the way from the top to the bottom of the laminate stack, from the guide steel over here to the inside, and now upstops. Unlike a steel roller coaster, the upstop area of most rides, most wooden roller coasters, there's nothing there in areas where there's no expected upstop contact. So at the bottom of the drop, in the station, and all those areas, there's nothing there. It's just blank wood. But when you go up over a bunny hill, if you go over an overbank turn or anything like that, then they put steel on the bottom side there. And just like everywhere else, the hardware comes up through the top, and now the hardware is pointing straight up in the air. Most of the time what we do is we drill and countersink everything, put it up underneath there, clamp it, run the hardware from the bottom to the top, and then tighten everything down. And once it's all tightened down, the carpenters typically come back with a cutoff wheel, and they will grind the top of that hardware off. And they just cut the top of it right off to where just a nut is left there. And a little bit, it's not much of the stud sticking out because they don't want it up too high. You're like, doesn't that affect the top steel? No, the top steel, remember, is over here. So there is actually this area between the guide contact surface and the top steel where it's just blank wood right there again. And that is where the upstop steel is anchored into. So with all that hardware crisscrossing everywhere, you can imagine this stack is really tight. Now, that stack also has extra special hardware where it crosses over the headers. The headers typically have metal plates underneath them, 90-degree at an angle, put up underneath there, and the entire laminate stack is anchored down through those plates to the header. Have you ever seen a train derail or heard about a train derailing on a wooden roller coaster? A lot of times what happens is that's in a high G-force area. Let's make a high G-force area. Bam! High G-force area. Check that out. Whoa! It's crazy. This is almost like it's like a 70-degree bank turn. Ridiculous. So much stress in this area, but the carpentry crew did a good job and everything's all nice and tight. But let's say the stack loosens. And when I say the stack loosens, what I'm actually talking about is the stack to the header. If the stack loosens up, it can start to twist. Because I don't have many screws in this, I can do it by hand. It'll start to twist, and then every time the train comes around, it pushes this open. It flexes just a little bit every time it comes through. Well, eventually, it pushes over far enough and it gets loose and flexes enough to where it comes over this way, and that actually allows the upstop wheel to come up from underneath the track. And now the upstop wheel is on top. Your train is officially derailed. That sucks. But that's how wooden roller coasters typically derail. They push the upstops, they push the laminate stack one way or the other, and the opposite side upstop wheel comes up from underneath the track right here. Right? Comes from underneath the track, and then as it's rolling along, it suddenly just goes and pops over the top. You could also have a failure in the laminate stack itself, just like I did, and you could mess up the laminate stack, which would also cause a derailment. But remember all the screws holding the top steel down? It's also holding the laminate stack together, so a little less likely. Splits in the laminate stack, I used all the same piece of wood here, but if I was doing a long run, the splits, as I start to open that laminate stack up, I stagger them. So I say, okay, my bottom laminate stack comes right here and then it stops. And then this next level up, I'm going to go down the track 4 feet and start it there. And then the next level up, I'm going to go down the track 2 feet, start it there. And then the next level down there, I'm going to another 2 feet and start it there. That way all those splices don't line up because that's all the stress right there. They all stagger in a diagonal line. So you have stagger, break, 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 break. And then top steel on top of that, again, not in the same area. Splices are always staggered like that to keep the stack tighter. All right, if you haven't already during this point in time in the video, like and subscribe because I'm making this video in the garage. It's hot. Man, I'm sweating like crazy out here. So I'd appreciate it if you subscribe, comment, like, do all that stuff downstairs. It helps me out. Subscribe button is just down there. It's off to that side over there. So let's talk about some creature comforts around the track. I talked about it earlier. You have walk boards on both sides. If I'm walking around the track to inspect the laminate stack, this is typically done by carpenters first thing in the morning. The mechanics take care of brakes, lift hill, control systems, booster drives, restraint unlocks, things like that. You typically have a carpentry crew that works on the structure. That they take care of all the wood. They have a really big stack of wood sitting in the back over there, and they're constantly working on stuff. They have sections where they know they have work to do. They prioritize stuff. They know what can be put off for another day. They know what has to be done that day before the ride opens, and they know enough that when they come across a certain type of problem, that they need to stop and call management out there, because they've pretty much, this ride's not going to run today, because they have a long-term thing. Like if you found a split header, where the header of the track down here was just, it went from a check to a crack. I remember check just a little bit, crack out to the hardware, and then split out to the other side. It's like, no good, it's done. We have to take the header out and replace the header. It's an all-day repair. We got walk boards out to the side like we were talking about. They got the handrails on both sides. That's for walking away around a track. And then one of the problems that they run into is there's two sections where they have to concern themselves. One is called a crossover section. Now this typically happens if you're, let's say, in a turn and it's hard banked to this side. So the walk boards will extend down to this side as I walk along the track. Okay, as the track levels out, then it's suddenly going to go, a lot of times, a lot of wooden roller coasters, they do a slalom type turn. As it levels out, then the track suddenly goes that way. Well, I can't stay on that high side because sometimes that banking is pretty steep. So right there, where the track goes from banked one way, level, to back the other way, right where it's level, you'll see this whole middle area filled in with wood for about 20 feet, 20 or 30 feet right there. It'll just be solid wood across the inside of the track. The reason they do that is because that is the place where maintenance, carpenters, anybody like that can safely cross from this side of the track to that side of the track and not have to worry about anything else. A little bit of controversy, and I could stand feedback here if you want to give me your feedback and let me know what you've heard about this, what you know about it. If you work on wooden roller coasters, especially, I value that opinion. Is a lot of times there is 1 to 2 boards running down the center of the track. And by that, I mean like this. There's a board running down the center of the track. Now, I've talked with a lot of people about this board, or sometimes there's 2 boards on there, and I can't get a straight answer. The first one I got is that the board is there so they can mount sensors on it, because a lot of times the board is mounted right where the brake fin of the train would be going. And that's typically where you mount sensors too. If you want to know where the train was, you mount a sensor on that board as the train passed over it. That was the first explanation I got. So I was like, okay, that makes sense. But I'm thinking to myself, why would you continue that board all the way around? Just the thought of putting a sensor in? I mean, I built this just now. Like, surely I could just go grab a piece of wood and screw it down inside the track to do the same thing. That didn't make any sense to me at all. So I'm like, well, what's the other explanation? What else? And I started talking with other people, and they said, oh no, that's in case you have a problem with the laminate stack and the train tries to set down for some reason, like where we're talking about derailing coming out. Someone was telling me that they're worried about the train going in. And this piece of wood is to prevent the brake fin from just completely careening into the header, or the ledger, and then just catastrophically messing up everything, bending the train apart and all that other stuff. So they said this is there in case the brake fin does set down, it will go up and over the header or ledger. And I thought, okay, but the wood's typically like 3/4 inch wood. In my mind, You set a brake fin down on a running train on a piece of 3/4 inch wood and go across like that, it's just going to split the wood in half. It's not going to do anything else. So the best explanation I heard so far is actually from my one of the state inspectors I work with. Really knew his stuff. And he said, well, if you think about it, where you would have to work all the time around the laminate track, he says, what's in the middle right here? And I'm like, there's nothing in the middle. What are you getting at? Well, the state inspector, at least in California, they are OSHA. They're a division of OSHA. So he says, quite simply, he says, that's a hole. That's a hole right there. Oh, so if you're familiar with industrial guidelines, you can't have big holes that employees can just fall into. You have to guard against the hole. So what that inspector told me makes the most sense that I've heard so far, and I'm open to other things because I'm sure there's many more ideas out there. That the piece of wood that lines the track like that in the center on a lot of rides, not all of them by any means, I see plenty of wooden coasters without this, that piece of wood that rides the center is simply to take up the hole. It takes a big hole and divides it into a smaller hole. It's like, okay, but as far as OSHA is concerned, once you get under a certain size hole, they stop caring about it. It becomes less it's more manageable at that point. The whole person's not going to fall through that little hole. They're going to fall through a bigger hole. Oh, during this whole time, I forgot one thing. You know what? I ran out of wood. Crap. Oh well. So you've got the headers or ledgers on both sides. And then you also have in between those, because a lot of times they're like 8 feet apart, you have what's called a cross tie. Can't believe I forgot about the cross tie the whole time. The cross tie is also to support the track. And it goes in just like this. It's beefy material. It's typically like a 4x4 material, kind of like your bent posts right here, but it's across the track going this way. And it's just meant to support the laminate stacks and help keep the gauge. Because on wooden roller coasters, where I was talking about the train derailing because it moves the laminate stacks can move. So it's necessary to anchor them down as much as possible to keep the gauge correct all the way down. Also helps maintenance out because it doesn't tear up the wheels as much. Okay, so, sorry, cross tie. I forgot about that way back when. Man, I got to start doing better on these things. Maybe I should start writing stuff down. No, we've all seen me read stuff. That doesn't work out well at all, does it? I'm not about to start reading stuff. So we've effectively built a section of a wooden roller coaster minus some steel on some surfaces here. What else do we need to talk about? Let's talk about the running surface that the wheels go on. Most wooden roller coaster wheels are not urethane, they are steel. It's steel on steel contact. What do you use to lubricate steel on steel contact? Well, we used graphite. It was wet graphite. You rolled it on with a roller down the track, and it turned the train absolutely black underneath. It was a mess. Oh, just an absolute mess. They make Track Lube Plus for wooden roller coasters. It's way better. It's like a wax-based steel. It's way better. It doesn't turn the track black. It doesn't turn the trains black. So much more environmentally better, I should say. But that's what you used on there. The reason for the steel on steel is because the trains need as much help with the energy as they can throughout the entire course. All right, throughout the entire course, the train loses lots of energy because wood sways so much. And then even though this is a really stiff, stout laminate stack, when the train passes over it, this entire stack between headers does flex down. One of the reasons people don't like wooden roller coasters is because they're so bumpy. They just rattle you the entire time. They're rattling you because everywhere you're passing between headers and sometimes even just across ties, the laminate stack is flexing. You'll also notice on old wooden roller coasters, really old wooden roller coasters, you will see your laminate stack is typically only about 2 boards high before they put the top board on it. Newer roller coasters, look at something like a GCI or something like that, something that has a lot of G-force into it, their laminate stacks are much thicker, because the thicker the laminate stack is, the more it could handle the stress of the ride. Also, the less flexing it does, which means the smoother it is. So that is one of the reasons why woodies get so rough, is because that laminate stack starts moving. Kind of back full circle, if your laminate stack starts moving and gets real rough like that, what's one thing you should do? Water the track. It makes the wood more flexible, which you would think would be a bad thing, but it actually smooths out the ride when you water the track down, and that wood starts to soak up the water, becomes more flexible again, less rigid. It's much better. So let's talk about hybrids. What's a hybrid? Well, hybrids is when they took this top laminate stack off or partially off and replaced it with steel. So the first, well, I shouldn't say the first, but the early predominant hybrids were what were called, RMC made them, called topper track. The topper track was essentially a steel overlay for this top surface here, and it turned this top rail into steel all the way around the track. It had to be bent and twisted and everything else, but that smoothed out the ride a lot, but it still required all of its anchoring. It still had to have the screws all the way down. It still required the laminate stack, and it was still prone to, you could V the gauge open and still mess things up. So it still required a lot of work. So they revised it. And the next step that came out, which is pretty much where most parks are right now when they do a hybrid, is iBox. The iBox is essentially this shape right here. It looks like a 7 or a backwards 7, depending on which way you're looking at it. The iBox is this entire laminate stack made out of steel. It's like an I-beam material with a square welded on the outside. And then that is bolted to a steel ledger. Now that's one of the times when I'm like, once it's steel, that's a ledger for sure. I know people will say, no, a ledger can also be wood, and I also agree with that. But RMC wise, once it's steel, it's a ledger. They built those steel ledgers across there, and then they put this steel iBox on top of that and bolt everything down. And now it's basically an RMC. It's a hybrid at that point in time. My bent posts didn't go anywhere. My external batters, my horizontals, my ribbon, all that stuff didn't go anywhere. All we did was we replaced the header and the laminate stack. Now, because those are steel, and steel doesn't move much at all, it's nice, and the steel is its own structure. It's simply just like this. It's just resting on top of the wood. What's up? How you doing? Right? It's just chilling out on top of the wood, anchored down all the way down the side of the thing. But because of that, now the structure isn't taking all that weight per bent as it crosses over. As it crosses each bent, all that weight isn't directly transferred into that one bent. All that weight goes across 15 bents in each direction. And now what used to be a lot of weight is now not a lot of weight. So the trains can get heavier. So they made heavier trains, which gave it more weight around the track. Now they're able to use nylon wheels. They're able to use urethane wheels to smooth the ride out even further. Because you don't have this laminate stack deflection between your bents all the time, because it's not sitting there going, now the ride's smooth. RMCs are typically smooth. They're not very rough out there. Does the structure still sway when it goes by? Absolutely, it does. In fact, a viewer sent me a video of the train going around the outside corner of where it already had a conversion, and you see the entire wood structure just go woof. They sent me the video because they're like, is this okay? Yeah, that's okay. Again, if it doesn't bend, it'll break. You want structures to move around. Even steel structures, they do the same exact thing. The difference is when you're looking at wood, you can tell because of the lattice work underneath it, you can tell like, oh, look how much it moved. On a steel roller coaster, you have no frame of reference unless you just happen to be looking across at another coaster in the background. Then you could see it. Oh yeah, I saw that sway a little bit. Go watch some off-ride videos at Nemesis. And because of the way that's in the terrain, when the photographer is still just watching the train go through a helix or a loop or something right there, you can see the deflection in the track really easy. As it goes around that bank corner, you can see the whole track sway down and then come back up as the train passes by. Wooden roller coasters, much easier to see. Once the train passes by, you can see the whole laminate stack, the structure, everything. It just has to go, oh, as the train passes by. It's done. It's like, whew. Lots of maintenance in this stuff. The Woody I worked on, it was a carpentry crew of 3 people daily that had to do that. And then the carpenters had to ride the train each time. Once each train had to be ridden, each train had to be ridden one time before the ride could open. And that was just a standard thing. That was the best thing I learned. I asked this guy, he was like 65, 70 years old, riding that roller coaster 3-4 times every morning. And I'm like, how do you do that without your back falling apart or everything else? Because, man, some Woodies are rough out there. Like, they are bad. And that's when he told me, sit in the restraints, sit in the coaster, pull the restraint down, get it nice and snug on you. And then he said, when you start riding it, when it starts going down the drop, put your hands across the lap bar in an X and hold the lap bar. So if you can see me here, do my demonstration. So I've got this, you put your hand on this side and hold the lap bar. And you've now created a triangle, 2 triangles backed up in the center. And when I ride wooden roller coasters, almost every time, especially if I don't know what the coaster is going to do, if I'm new to that coaster, I ride it like an X every single time. And you know what? I have not been disappointed by that. It has made rough rides smooth for me. So try the X sometime if you can. Sometimes the restraints don't allow it because they're, old Philadelphia toboggan company style where they're up high and stuff like that. But if you can get on the outside of it, do it. It's the best thing. All right. So we covered the structure, construction. We talked about steel. We talked about maintenance. For the mechanics working on wooden roller coasters, the number one thing that they spend a lot of time doing, the trains are beaten up pretty good out on old woody tracks. So they just, a lot of hardware replaced and stuff like that when a bolt snaps or something like in those lines. But the mechanics will spend most of the time fine-tuning the speed. Speed on wooden roller coasters is very critical. If they go too fast, they tear up the laminate stacks and the gauge gets all messed up. Wooden roller coasters don't like going fast, but if they go too slow, they valley. And the mechanic has a lot of control over that speed with the wheels. How much grease, how much oil, what weight oil goes inside those wheels. I know in the summertime when our GCI was running super fast, we would put straight 30 weight oil in the wheels and fill the wheels up with 30 weight oil, and it would just blow around that track, no problem all day. Run like a slug in the morning time. Please come back, please come back, please come back. And when it started getting cooler and we started getting into the off season, we would start adding automatic transmission fluid to those wheels. And that would start thinning out that oil. And then eventually the mechanic would bite the bullet and drain the wheels out of all the oil and just put straight transmission fluid inside. It was very thin, got out of the way of the bearings really fast, so those wheels were able to go, so able to pick the speed back up when the ride was running cold. The rest of the time spent doing lift hills and things like that. Lift hills and brakes. When we talk about those two guys, the entire structure still applies, but when it comes to lift hills and brakes, both the lift hill, the chain, the anti-rollback rails, and the brakes, the segments in there, are all mounted directly to the headers or the ledgers. There's nothing in between, because that is what has to take the weight and the stress of the entire assembly. So the track still has cross ties running across there, but where the lift hill, like chain trough and any rollbacks pass over that cross tie, there's nothing there. It's not anchored to it. It's only anchored to the header on both sides. The same thing with brake assemblies. They pretty much stretch long enough to go right into the headers. If they don't, they use some really beefy planks of wood underneath there, typically reinforced like 2 boards thick, and anchor the brake to those. And then there's lots of extra anchoring around that. But typically in the brake run, the bents actually get closer together, like distance between here and here. They actually get closer together to handle more stress of the train slowing down repetitively in that area. Also, in those areas where the train is transitioning, slowing down, or speeding up, your ribbon boards also go under more stress. So the ribbon boards are they're anchored a little better in those areas. Instead of just like the 2 bolts in there, they might start throwing 4 bolts in there, or they might start clamping them into the sides as well. That takes the stress of the structure going like this all the time. Because the bents are great in general, but without the ribbon and the other batter boards and stuff like that around the outside of them, they would flop around too much and the entire structure would just fall apart. Okay, I'm hot, sweating a bunch. I hope you've enjoyed this video. I enjoyed playing with my trash. It's a roller coaster piece from trash. Pretty cool, right? All right, I'm Ryan the Ride Mechanic. Again, like, subscribe, comment, do all that stuff. It does help me out. Let me know if you got anything. I'm assuming I'm going to get lots of comments on the terms on this one. Corrective, whatever. This is kind of just what I know. Like I said, there's a lot of terms out there. Lots of terms. If you want to contact me, you can always email me at ryantheridemechanic@yahoo.com. Or you could just comment downstairs. That's perfectly fine too. And in the station, most wooden roller coasters, especially newer ones, also have air gates. And you should also stay off the air gates. Bye.